my dear. Part of the come. So actually, soil stock like to cover the origin of soil stock. My dear student, soil mechanics. So soil mechanics is a civil where it mechanics, also hydraulics related to the engine. So actually, soil mechanics understand the nature of whether the soil is dense, whether the soil is also understand where the soil, and we also have to understand what are the different soil structures, what are clay mineralogy, all these topics we going. So if you really like, I will ensure you 100% quality content on IMS. So it is my sincere advice of you, please share this because the students who are real gate aspirants will benefit. So let us start the topic origin of soil. I want to start with the topic origin of soil. So in origin of soils, when I talk about the origin of soils, students, as I told you, the study of soil is meteorology. So when you are discussing about the origin of soils, the first question is, how do soils are formed? So here the first question you can ask me, how do soils are formed? This is the first question everyone will ask me. Start with the topic origin of soil. What is the study of soil we call? Now, how do soils are formed? Sir, if you have a huge rock, the rock gets withered and it forms a type. So, how do soils are formed? Soils are formed by weathering of rocks, decomposition of organic and inorganic. So, what is the, we can write here, how do soils are formed is, soils are formed by, please write down these students, soils are formed by weathering of rocks, soils are formed by weathering of rocks, weathering of, and decomposition of organic and inorganic matter. Decomposition of organic and inorganic matter. So they can ask you here, student, how do soils are formed? Soils are formed by weathering of rocks and decomposition of organic and. Now here, see student, organics. Now here, I would like to tell you, what do you call organic soils? What is the name associated with organic soil? This is the previous question and I is objective. Now see student, organic soils are known as humus soils. What is the name given to the organic soils? Organic soils are known as humus soils. Here, the example of humus soil is peat. Peat is nothing but the decaying vegetable. The vegetables, after they are getting bad, you will get a pungent smell. Decaying means the vegetable get rotten. So peat, and we also talk about humus. What is a humus? Is nothing but a cow dung or any solid. So, what are organic soils are called, my dear students? Organic soils are nothing but the humulose soils, and the example of organic soils is but peat and humus. Here we have peat called the decaying vegetable matter, and the humus is nothing but the soil. Now, when I talk about how the soils are formed, you should understand a cycle. See, my dear students, if you see how the human body forms, there will be a human cycle. For butterfly, any formation to have a cycle. So, similarly, my dear students, soils are formed by a cycle known as geological cycle. So, what is geo? It is nothing but earth. So, a soil is formed from the earth. So, we call it as geological. Am I clear, my dear students? So, let us write the geo is nothing but the earth's crust. Soils are formed from the earth. So, soils are formed by the cycle known as geological cycle. Now, my dear students, what are the different stages in geological cycle? See, this is very important, my dear students. The first stage where we have is the withering. See, students, the rock gets withered. Okay, we'll discuss what are the different types of withering also. First of all, what is the first stage of geological cycle is the soil gets withered. After withering, this soil will be transported by means of air or water. Suppose if you have a river, along with the river, there can be some soil transported. Or if you have seen in deserts, a lot of air will come and there can be a transportation of land. So, by means of air and water, the soil gets transported. So, the first stage of soil is withering. In the geological cycle is withering. We call it as withering. And the second stage is transportation. Now, my dear students, once the soil gets transported, the soil has to deposit at some place. So, the third stage here is the soil gets deposited. So, here this is called as the third stage, where we call it as deposition. Okay. Now, see students, the soil gets deposited. It forms like a upheaval. And the fourth stage is upheaval. The fourth upheaval. Sir, you will ask me, my dear students, what is upheaval? Upheaval is nothing but, according to the dictionary meaning, it is the rise in the earth's crust. So, as you arrange the soil, there will be a rise in the earth's crust. That is nothing but the upheaval. So, what are the different stages of geological cycle is? We have the first one is the withering part, and the second one we have is the transportation, and the third one is deposition. After deposition, we'll be seeing the upheaval part. So, these are the four stages in the geological cycle. Now, coming to the withering part, what do you mean by withering? What are the different? In withering, my dear students, we have two important parts. One is the physical withering, okay, and another one is the chemical withering. So, there are two stages in withering. One is the physical withering, and the next one we have is the chemical withering. Now, my dear students, what comes under physical withering? What comes under physical withering? So, here I would like to tell you, physical withering is observed in coarse-grained soils. It is observed in coarse-grained soils. The example for coarse-grained soils are nothing but gravel and sand. Now, see students, what comes under physical? So, physical weathering is due to the natural effects. So, there is no additional process for the physical weathering. No external process is done. So, what are the physical process we are doing is, these are due to the melting of the ice, or when a banyan tree spreading of plant roots, the soil gets withered, or due to the temperature change, the physical weathering will occur. So, physical weathering is observed in coarse-grained soils, And the physical weathering is observed due to the natural effects. It can be due to the change in temperature, or it can be due to the change in the melting of ice or spreading of plant roots. So this comes under physical weathering. Now, my dear students, when I talk about the chemical weathering, it is observed in fine-grained soils. It is observed in which soils? Fine-grained soils. And in what are fine-grained soils are nothing but the fine-grained soils examples are nothing but clay and silt. So fine-grained soils are nothing but clay and silt. So where do you observe this chemical weathering is? Chemical weathering is observed in fine-grained soils. And the example for chemical weathering is clay and silt. So what comes under chemical weathering? Now, simple issue, my dear student. You have a huge rock, and if you pour a hydrochloric acid on the rock, it will never have an impact. But if you draw hydrochloric acid on a tiny particles, there can be some chemical reaction. So what occurs in chemical weathering is, the chemical weathering can be due to the oxidation, which is due to the oxygen, can be due to hydration, due to hydrogen. It can be due to carbonation. We also have leaching. So what comes under chemical weathering is due to the chemical effects. And this chemical weathering is observed in fine-grained soils, that is clay and silt. I hope you are clear with the weathering concept. Now see students, I would like to discuss about two important soils. One is the residual soil. One is the residual soil. And other one we have is the sedimentary soil. Other one we have. So we have two types of soils, my dear students. Broadly classified. We have different types of, but broadly classified into two things. One is the residual soil and other one is the sedimentary. Now, my dear students, what actually is a sedimentary soil? A sedimentary soil is nothing but a soil particles created at one location and finally deposited at another location is nothing but a sedimentary. So this is very important. So when I talk about sedimentary soils, we have the most important thing is soil particles create at one location, soil particles create at one location, soil particles create and finally deposited, deposited another location. Soil particles create at one location, finally deposited another location, known as a sedimentary soil. Okay. So, my dear students, to remember this sedimentary soil, you can write it as transported soil. So, the name itself, it says that soil particles create at one location and finally deposit at another location. Now, when I talk about the residual soil, these soil particles which remain on the parent rock, soil particles which remain on the parent rock, soil particles which remain on the parent rock without any transportation, without any transport. Is known. So here we have two types of soils. Residual soil, we can remember it as non-transport. When I talk about sedimentary soil, these you can remember as transport. So soil particles which remain on the parent rock without any transportation is known as residual soils. Soil particles create at one location and finally deposit at another location is known as sedimentary soil. Now, what comes under sedimentary soil? Suppose if you have seen soils which are deposited in river, these can be the questions. whatever the soil which is deposited in river, call that soil as alluvial soil. Or in one of the objective questions in the state level exams or anywhere, we can ask you, what is the most fertile soil? The most fertile soil is nothing but the alluvial soil. So that is the reason, students, if you see the civilization, Indus Valley civilization, Harappa culture, wherever the civilization starts, it starts on the banks of the river, because whatever the soil which is deposited in the river, it is having more fertile, and that will help for the growth of the cultivation or a crop. Now, my dear students, when I talk about the soils which are deposited in lakes, we call it as lacustrine soil. All the soil which is deposited in lakes known as a lacustrine. Similarly, the soil which is deposited in sea, whatever the soil is deposited in sea, we call it as a marine soil. Okay. Soils which are deposited by wind. This is important, my dear student. It was one of the time asked in. Soils which are deposited by wind are known as 2020 or somewhere it was asked. Soils which are deposited by wind is nothing but the aeolian soil. Now, my dear students, you can ask me where actually these soils are found. These soils are found in deserts. Just by blowing the wind, the soils are formed. And the example for these wind deposited soils are sand dunes and losses. And these soils are observed where? These soils are observed in the deserts. So here this you have to understand, the most collapsible soil. Just by blowing the wind, the soils are formed. The soil structure is also not consistent. So here the most collapsible soil, this is important and it is a previous gate question. All these soils comes under sedimentary soils, okay, not the residue. These all comes under which soils, sir? Sedimentary soils only. So here, my dear students, when I talk about the wind, we call wind soils as alien soils. Example of wind soils are sand dunes and losses. And these soils are observed where, my dear students, is these soils are observed in the deserts. Now, similarly, when I talk about the soils that are deposited due to gravitation, suppose due to the self weight, the soils are formed. So, gravitation soils which are formed due to gravitation, they are called as colluvial soils. And this is happening due to, you observe these colluvial soils, the mountainous regions. And the example for colluvial soils is talus. And these are observed where? These are observed in terrain. And next we have the glacier. Glacier is nothing but the soil. So glacier, due to snow, we call these soils as glacier deposited soils. And the example of glacier deposited soils like Kashmir or in the Switzerland, where the snowfall is more, you observe this. And the example for glacier deposited soils are, example is but drift, till. Example for till. I hope you are clear. So what are the different types of soils we have in the sedimentary? The soils which are deposited in river are called alluvial soils, and it is the most fertile soil. And you can also write soils which are deposited in lakes, lacustrine soils, and soils which are deposited in sea are called marine soils, and soils which are in wind are aeolian soils, and it is the most collapsible. And gravitation soils are colluvial soils. Example is talus. Glacier deposited. Example is drift. I hope you are clear with this. So let us move on to what is the example of residual soil. Now the example of residual soil is nothing but the black cotton soil. The example of residual soil, you can write example of black cotton, sample of residue, what? Nothing but the black cotton soil. And remember, my dear students, black cotton soil, black cotton soil have high swelling. Black cotton soil has high swelling. Swelling means bulging. And shrinkage is nothing but the volume reduction. I'll discuss in the soil why it is like that and all in the soil structure. Now, my dear students, when I talk about the black cotton soil, they can ask you what is the parent rock. Most of the people think it is the parent rock for black cotton soils is not ballast, it is basalt. Some people remember it as ballast. Ballast means you use in railway tracks. Okay, here it is the parent rock of black cotton soil, basalt. Now let us discuss which forces are predominant or more. See, the name coarse grain itself will have more self-weight. So remember, my dear students, this is an important point in the application point of view. Gravitational forces, that is due to self-weight. You can write here, gravitational forces are more where? Gravitational are more in coarse grain. There is where do you observe gravitational forces? Gravitational forces are more in of soil, more in the coarse grain, or you can say predominant. Whereas surface, chemical and electrical forces are more in surface, electrical forces are more in where? Or predominant in fine grain. Surface, chemical, electrical forces are more in which type of soils? Are more. So I hope you are clear which forces are predominant. So why the gravitational force? Or because the coarse grain itself, the weight of the particle and why surface and chemical are there? Because as usually I told you, how fine grain particles are formed. Fine grain particles are formed due to chemical analysis. That is, the chemical forces are more in fine grain. Now see, different compositions are also there. We have a concept called warped clay. What actually do you mean by warped clay? What actually do you mean by warped clay? The name itself, warped clay, contains alternate layers of warped clay. What do you mean by warped clay? Contains alternate layers of warped clay. What? A, what do you mean by warped clay? It contains alternate layers of clay and silt. What do you mean by alternate? There will be some depth of clay, x some depth of silt. The soil composition is of that order. We call that soil as warped clay. Next one we have is the morum. Morum is nothing but the gravel mixed with gravel red clay. Whatever the gravel mixed with red clay is known as. So here, my dear students, I would like to tell you what is warped clay. The warped clay is nothing but the alternate layers of clay and silt. And what is morum is gravel mixed with red clay. Next we have is warped clay, morum, and also loam. So these are the different soil compositions. A loam is a mixture of sand, silt, clay, equal proportion. Sand and silt in equal proportion. So here I would like to tell you, this is very important. So a mixture of sand, silt and clay in equal proportions. nothing but the loam. So we have different soil composition. Borrowed clay contains alternate layers of clay and silt. Morum, gravel, mixed red clay. Loam, a mixture of sand, silt, and clay, equal proportion. We also have a term called bentonite. Now, my dear students, when I talk about bentonite, it is a type of soil is decomposed by volcanic. It has volcano after when the volcanoes erupt, there will be fly ash coming from the volcanoes. Due to that fly ash, this soil is formed, and this bentonite will have very high swelling and shrinkage due to the presence of a clay mineral called montmorillonite. So this is actually the different types of soil. What are the different types of soil composition, my dear student? We have the one is the warwood clay. A warwood clay is nothing but the alternate layers of clay and silt. We have the morum, that is gravel mixed with red clay. And we also talk about the loam, a mixture of sand, silt, and clay. And what is bentonite is, it is decomposed by volcanic ash, and it has high swelling and shrinkage due to the presence of a clay mineral called montmorillonite. Now, let us discuss the topic soils. To understand the properties, engineering properties, my dear student, to understand the nature of the soil, to understand the nature of the soil, we study the origin. And to understand the behavior, how the soil has formed, what is the soil structure, based on the structure, we can tell whether the soil is dense. What are the engineering properties associated with that? We will be learning in the soil structure. So, my dear students, what exactly is soil structure? A soil structure is nothing but the geometrical arrangement of soil particles in a soil mass. What is a soil structure? Soil structure is defined as the geometrical arrangement of soil structure is defined as the geometrical arrangement of soil particles. It is defined as the geometrical arrangement of soil particles in a soil mass. Is nothing but the geometrical arrangement of soil particles in a soil mass, nothing but the soil structure. So we have to study this. What do you mean by soil structure? It is the geometrical arrangement of soil particles in a soil mass. Now see students, based on the formation, based on the soil formation, based on the soil structures are classified different structures. Okay, based on the soil formation, soil structures are classified into different structures. One is the single grain structure. Is the single grain structure. Next we have is the honeycomb structure. Next one we have is the flocculator structure. The last one we have is the deposition, or you can write dispersed structure. We also have a composite structure. We also have a structure called composite. So what are the different, based on the mode of formation, based on the mode of soil, based on the mode of soil formation, soils are classified into different structures. One is the single grain structure, honeycomb structure, flocculator structure, dispersed structure, and the composite. So let us understand what is a single grain structure. See students, this is a very important also. Now what actually do you mean by single grain structure? Usually when the coarse grain particles, due to the self weight is more compared to the fine grain, the soil, due to its weight, they settle and the soil will be arranged very closely. Are you getting, my dear students? What is a single grain structure is, the soil particles are assumed as a spheres case of coarse grain, and due to the weight, the soil is formed. And when the soils are closely formed, definitely the void ratio will be less. So if you see in single grain structure, the particles are closely spaced, the void ratio will be less. So in this case, by practical observation, we have got the maximum void ratio as 0.91. Here the soil particles are assumed as the, if you consider in case of loose, obviously the void ratio will be more. Here the void ratio will be. Sir, see, this is another important thing. Here you are telling that this is a dense soil, right? So in case of dense soil, the void ratio will be minimum. This is a very important concept. That is 0.35. Sir, when the soil particles are close to each other, the void ratio will be less. But in case of loose soil, when I talk about a loose soil, in this case, my dear students, the void ratio will, maximum. So what is the maximum void ratio? It is equal to 0. So where do you observe these single grain structures is? This type of structure is observed in coarse grain soils. What are coarse grain mean? You can write it as gravel and sand. So in single grain structure, when I talk about the loose case, the void ratio will be maximum, and in case of dense case, the void ratio will be. So let us understand the most important structure, that is the honeycomb structure. Now sir, this is known as the honeycomb structure. We also have to discuss about the next structure, honeycomb. Now when I talk about honeycomb structure, what do you mean by the honeycomb? How do you define this? Sir, you know honeycomb structure is something like earrings. So here, if you see, the structure will be looking in this way. If you see the structure of the honeycomb, will be something of this. So whatever the space in between them, nothing but the voids. So here, honeycomb structure, this was a previous gate question also, my dear student. So where do you observe this honeycomb structure? It is observed in, honeycomb structure is observed in, fine sands. Honeycomb structure is observed in fine sands and silt. Where do you observe this honeycomb structure? Honeycomb structure is observed where? It is observed in fine sands and silt. Now tell me, sir, as this entire space is nothing but the voids, this is the voids, so obviously it is a very weak structure. Under small vibrations, you just disturb the soil will collapse. So we have to avoid the honeycomb structure to improve the bearing capacity of the soil. So my dear students, honeycomb structure is a very dangerous structure, and it is observed in which type of soils? Fine sands and silts. So here you can write under silt, under small vibrations, structure will collapse. Under small vibrations, structure will okay. So here we have two structures. One is the single grain structure and honeycomb structure. How to avoid honeycomb? Because under small vibrations itself, the structure will collapse. Next one we have is the flocculated structure. Next one we have is the flocculated structure. Now when I talk about the flocculated structure, how the structure will look like? Okay. Suppose if the structure is looking like this. Now where do you observe this flocculated structure? This structure is observed in case of clay. And how this structure is formed? Remember, my dear students, This structure is formed between the net attraction between soil particles. So here if you consider this as edge, it will be the face. And here you will see a orientation of edge to face orientation. So how does the flocculated structure form? See, it is formed by the flocculated structure is formed by the net attractive forces is formed by the net attractive net attractive forces formed by the attractive soil particles formed by the net attractive soil. And remember, my dear students, how this flocculated structure is formed. It is formed by the edge to face orientation. How it is formed? Flocculated structure is formed by the edge to face. So here, my dear students, you see about the flocculated structure, it is formed by the soil particles due to attraction. So the soil particles will be closely spaced. So compared to the other structures, it has less voids. So that is the reason, due to flocculated structure, it has high shear strength, low compressibility, and high permeability. As high shear, based on the shear strength only, the bearing capacity will be decided. And low compressibility. What is compressibility? Means removal of both air and water, known as compressibility. And next one we have is high permeability. Actually, you can ask me, sir, you are telling it is having high shear strength, but then how the permeability will be more? Because the size of the void is more. Actually, the permeability depends upon the size of the void. So here, this is a very important term. What are the properties? How the properties are there in flocculated structure? It has high shear strength, low compressibility, and permeability. What do you mean by permeability? Means it is nothing but the water flowing capacity. Suppose if you have a tank, if you open the wall, the water will flow. So what is the water flowing capacity in a soil is nothing but the permeability. Hope you are clear. So this is what we discussed about the flocculated structure. Next one we have is the dispersed. Next one we have is what? One we have is the dispersed. Okay. Now, my dear students, when I talk about the dispersed structure, okay, how this structure is formed. See here, if you see the orientation of the clay, this is how the orientation will be. So here it is formed due to the face-to-face orientation. So like particles will always repel, right? So here the orientation, if you see from the diagram, will have face-to-face. So dispersion structure is formed due to face-to-face orientation. And how due to these like poles, they repel. So actually this dispersed structure occurs due to the repulsion between the soil particles. It occurs due to the repulsive forces between the soil, occurs due to the repulsive force, soil particles. So here what do you say dispersed structure? Dispersed structure is observed in which type of soil? This is observed in which type of soils? Observed in remolded clay. So what do you mean by remolded? I will tell you. Actually, remolded, due to remolding, what will happen? The loss of strength is. So this kind of dispersed structure is observed in remolded clays. And whatever the behavior in dispersed structure, it is formed due to the repulsion. and here it is formed due to the face-to-face orientation. So whatever the properties which you have observed in the flocculated structure will be a vice versa here. So here you will have low shear strength, you will have a low shear strength, high compressibility, and low permeability. So, so these are the different properties which are observed in the dispersed. Now, my dear students, I will explain you a small topic here. So let's. Now see students, you have heard the term called elasticity. If suppose, what do you mean by elasticity? If a body is subjected to some, when the body is subjected to some force, there will be some change in length or there can be reduction in length. So when you remove that force, the body will regain its, then you say that the property is having a proper elasticity or elastic property will shape. Or use simple words, elasticity is defined as the property where it regains its size and shape, nothing but elasticity. So similarly, my dear students, in soil also we have one property. That property is nothing but the thixotropy. Property is what, sir? Thixotropy. So what actually is thixotropy? The phenomena of regain of lost strength with the passage of time. So you cannot regain the strength immediately. It will take some time. The phenomena of regain of lost strength with the passage of time without any change in the water content known as thixotropy. So let us do this. First of all, what is thixotropy? Is the phenomena of regain of the phenomena of regain of the phenomena of regain of lost strength, phenomena of regain lost strength with the passage of time, with the passage of time. You cannot regain the strength immediately. It will take some time to regain the, with the passage of time, with no change in water content. There should not be any change in water content. No change water. Am I clear, my dear student? So thixotropy is a kind of property like elasticity. You are trying to regain the lost strength with the passage of time with no change in water content. Now, first of all, you will ask me one question. Sir, how the strength is going to lose in the soil? The strength is going to lose due to remolding. What will happen when you do remolding? You want to make a different shapes. Remolding causes loss of strength. What made the soil to lose the strength? Another way. Remolding causes loss of holding causes what? So what is thixotropy? The phenomena of regain of lost strength with the passage of time with no change in water content. Thixotropy and remolding causes what? Causes the loss of. Now let us see. Now when I talk about the clay mineralogy, when I talk about the clay mineralogy, talk about the clay. We have different types of clay minerals. One is the first clay mineral is chalonite. They can ask you which is the most stable. It's a very important question, my dear student. The clay mineral which is the most stable clay mineral is nothing but the kaolinite. Agree? So what actually is kaolinite is the most stable clay mineral. They can ask you which is the most stable clay mineral is. The most stable clay mineral is nothing but the kaolinite. And what is the example of kaolinite is China clay. Because as it is a stable clay, China clay, or you can say porcelain clay. Because when you do ideals, or if you see in Vinayak Chauthi, we call Vinayak Chauthi, or in when you during the Lord making of it, that they might be using porcelain. So kaolinite, how does the kaolinite looks like? Is so here you can write here kaolinite. It looks like G, and most of the people will think it is gravel sand. Gravel sand it is not gravel sand. It is gibbsite silica, gibbsite and silica. It's a composition of that seed. And this was a previous gate question also. Name the clay mineral, the clay mineral, the clay mineral, which is formed by potassium ions. The clay which formed by the clay, the clay potassium, whatever the clay mineral which is potassium, what we call it as elite. That clay mineral is as what, my dear? We call that clay mineral as what? Elite. So here when I talk about the elite, how this structure will look. Our here, whatever the thing this can also. Now see student, as I told you, what is a step? You are telling, you have told kaolinite is the most stable mineral. Now when do you say that the mineral is not exhibiting any kind of swelling or shrinkage, then we consider that mineral as the most stable clay mineral, and we have here kaolinite. So we have two types of soils. One is the kaolinite, which is the most stable clay mineral, and the example of kaolinite is nothing but chain. And you have to tell me, in the clay mineral which is formed by the potassium ion is nothing but the elite, and elite clay mineral will exhibit medium swelling. Agree? The next one we have is the montmorillonite. Monto. So what actually is montmorillonite is? Name the claim, the most. Montmorillonite is the most. Montmorillonite is stable clay mineral. Why it is called most unstable mineral? It has very high swelling and shrink. The example is not, but you observe this in black cotton. Has very high swelling. Case is nothing but the volume reduction, and swelling is nothing but the bulging. So here what I would like to tell, what do you mean by montmorillonite? The most unstable clay mineral. It has clay mineral and it has very high swelling. Now, what are the examples of montomornal? Is nothing but the black coat. And remember, students, halosite. There is another clay mineral also, halosite. And remember, how does this montmorillonite look? This is formed by water molecules. That is the reason montmorillonite have high swelling, and as it is formed by the water molecules, due to the water, there will be high swelling and shrink. Here, my dear students, so montmorillonite is the most unstable clay mineral, and we don't encourage this soil in place. Why it is having high swelling? And due to the presence of water molecule. Due to the water molecule has high swelling. Now, my dear students, halosite. Halosite behavior is similar to kaolinite. Talk about the halosite. The halosite behavior is similar to kaolinite. Now, my dear students, as a you are least bothered about the chemical analysis or anything. You are bothered about the engineering property. So here, when you say that the halosite is having the behavior similar to kaolinite, the halosite behavior is also the stable claim. You can say that kaolinite and halosite the most stable clay mineral. This was a famous gate question. Name the stable clay mineral. It is kaolinite. Name the clay mineral which is formed by potassium ions. It is a previous gate question also. Illite. Name the clay mineral is formed by the water molecules is montmorillonite, and kaolinite is the most stable mineral. When do you say that a mineral is most stable? Is when it having no swelling and shrinking. When the mineral is not exhibiting any kind of swelling or shrinkage, then we say that the mineral is the most stable clay mineral. Now, next I want to ask you one important topic, that is specific surface area. Sir, whenever I start this topic, I ask the students very simple question. What is the area and what do you mean by surface area? So, what is the area of a rectangle, sir? What is the area of a rectangle, my dear student? It might be L into B. Then what will be the surface area of rectangle? Is it L into B or any other? Just think of it. Just think of it, sir. So, remember students, area and surface area for two-dimensional bodies is surface area comes into picture in three-dimensional bodies. That is the reason if you talk about cuboid or a cube, you talk about the total surface area or you talk about the lateral surface. Now, what do you mean by specific surface area? Specific surface area means it is the surface area of, specific surface area is defined as surface area of soil particles, is the surface area of the soil particles. The surface of soil particles present in. Okay, what do you mean by specific surface area? Is the surface area of soil particles present in. So the units of the specific surface area is nothing. Centimeter square per gram, or it can be written as meter square. So what do you mean by specific surface area? Specific surface area of the soil particles present in unit weight. Here the units are nothing but the centimeters per gram, or it can be the meter square. Now when I talk about specific surface, finer the soil, there was a finer the soil, higher the specific. Because when I talk about the arrangement, they have n number of soil particles more. is fine grain. I'll tell you how it the explanation. Finer the soil, you can write higher the finer the soil, specific so here please understand this surface area is defined as the surface soil particles present in finer the soil, higher the surface area. What do you mean by finer the soil, higher the when the soil is fine, to take 1 kg, there will be more number of soil particles. Soil is fine. So when you arrange them, there obviously their length will be more. That is the reason finer the specific surface. You can see the order. Colloids will have the highest. After colloids, you see the specific surface area order, increasing order. It will be colloids more than clay, clay more than silt. Silt will have more than gravel, sand will have more than. So as the particle size increases, the specific surface area decreases. As the particle size decreases, the specific surface area. Okay, I hope you are clear with the terms. So let us conclude this. A specific surface area is defined as the surface of soil particles present in you. Finer the soil, higher the specific surface. The units are centimeter square per gram or meter square per gram. Here you can also take that the specific surface area for colloids is more than clay, more than silt. Okay. Next, we have a term called diffuse double layer. Students, actually, this also use mostly the concept of so if you want to understand the groundwater techniques, you should have an idea on the diffuse double layer. So what exactly is diffuse double layer is here. If you consider this as the shape of clay particle is angular or flaky. So if you see the arrangement here, now this we call it as ridge layer. This we can call it as. Now what actually do you mean by diffuse double? First of all, see this clay particle with charge negative. So here we call this as of what actually double layer is the layer on the clay surface up to limit of attraction due to the electrical force. This method or this concept may be helpful in the ground improvement. So I write here the layer on the clay surface on the clay surface up to the limit of attraction of attraction due to up to that limit of attraction due to electrical forces on the clay of attraction due to electrical forces on the clay of attraction. Electrical forces is known as simple topics. You have two magnets. The magnets are close. the soil particles tend to attract. If you move the distance, then it will soil particles. So that is the reason when you see the soil particles, they are rigid. So they are more apart, they will become. So what actually is diffuse double layer is the layer on the clay surface, the limit of attraction as diffused double layer. Now, whatever the water held in this zone, whatever this water held in this zone is known as absorbed water. You can write here water held in the zone of water held in the zone water held in the diffuse double layer, whatever the water which is held in the zone of diffuse double layer as what? Absorbed water. Okay. I can ask you whatever the water which of double layer, water held in diffuse double layer is known. Now, what happens when there is an adsorbed water? Absorbed water causes elasticity. What happens? Absorbed water causes plasticity. Sir, you might have think plasticity in terms of consistency. It offers resistance to deformation. Plasticity means allows the deformation, but still a plasticity always a dangerous soil. As adsorbed water causes plasticity, we are using instead of adsorbed water kerosene, and kerosene will not cause, okay, kerosene will not cause kerosene will not cause plasticity. Plasticity. Why it will not cause plasticity? We talk about kerosene is a non-polar liquid. As kerosene, because what is polar, non-polar means on the mode of attraction. Term is. So here you can write that adsorbed water causes plasticity, and as kerosene is a non-polar liquid, not cause. So let us see what actually is diffuse double layer. The layer on the clay surface up to the limit of attraction, diffuse double layer. The water held in the zone of diffuse double layer as what, my dear student, is nothing but the adsorbed water. But remember, student, this adsorbed water will cause plasticity. So to overcome that plasticity, we are replacing that adsorbed water with kerosene. Why kerosene will not cause plasticity? Because it is a non-polar liquid. As kerosene is a non-polar liquid, not chlorine. So let us do the summary of the topic related to the origin of soils and soil structure. So we are going to discuss the summary of origin of soils, also the soil. So here, what is actually soil mechanics? It is a branch of engineering. The mechanics and the hydraulics engineering application. The study of the soil is known as, what is you mean by origin of soil is, so here origin of soil, the first, how do soils are formed? Soils are formed by the weathering of rocks, composition of organic and inorganic matter. Organic soils are called soils. The example for cumulus. Now, next, how this soil is formed by a cycle, geological cycle. Geological cycle, we have withering, transportation. After transportation, going to deposit, and that deposit will upheave. So we have two types of withering. One is the physical weathering, other one is the chemical weathering. So physical weathering is observed in the coastline, and it is due to the natural effects like melting of ice, temperature change, spreading of plant roots. And chemical weathering is observed in fine grain, so oxidation, hydration. And remember, my dear students, we have soil is broadly classified into parts. What is the transported soil, and another one is the non-transported. Transported soil is nothing but the soil particles created at one location, finally deposit another location, is nothing but the sedimentary soil. Soils which are deposited in river are called alluvial soils. It is the most fertile soil. Soils which are deposited in lakes are called lacustrine soils. Soils which are deposited are called marine soils, and soils which are deposited by wind are called aeolian soils. The example is the sand dune process. This is the most collapsible. Soils which are formed due to the gravitation called alluvial soils, and example is talus. And when I talk about the soils which are deposited by glacier, they are called as glacier deposited, and the example is Rift Kamat. Here, similarly, we have the next residual soil. What actually is a residual soils is soil particles which remain on the parent rock without any transportation. Gravitational forces are predominant in coastline. Surface chemical forces are predominant. Remember, water clay contains alternate of clay. Morum means gravel mixed with red clay. Bentonite is decomposed by volcanic. Loam means mixture of sand, silt, and clay. Coming to the soil structure, what actually do you mean by soil structure? Is the geometrical arrangement of soil particles. So how the soils are arranged based on the soil structure, based on the mode of formation, the nature of the soil, you can understand the soil property. We have different types of soil structure. One is the single grain structure. It is observed in coastline. Soil particles settle on it. You will have the void ratio 0.3. The void ratios are far away than in loose void ratio. Here the soil particles, and they are arranged in a arranged. We have the next one is the honeycomb structure. Remember, as a avoid the honeycomb because it is very. That is the reason it is stored in fire. And this structure under small vibration, the structure will collapse. Next one we have the flocculate. It is formed by the net attractive soil part. It has edge to face orientation. It has high shear strength, low compressibility. Dispersive structure is formed due to net repulsive force of soil particles. It has low shear strength, high compressibility, low permeability. This structure in red clay. What is a composite structure? Composite structure aligned together is. When I talk about the thixotropy, it is something related to like elasticity, the phenomena of regain of lost strength with the passage of time, with no change in water content, is nothing but the thixotropy. And we also discussed about the different clay. Kaolinite is the most stable clay, and it is the example is China clay. Name the clay mineral which is formed by potassium iodide exhibit. And we have montmorillite which has high swelling water molecule. Halosite behavior is. We have a term called is the surface of soil particles present. So the unit of specific surface area meters per gram or meter square. Finer the soil, higher the specific surface area. So colloids will have more when compared to have more. So finer the soil, higher the specific surface area. And remember, usually when they told you specific surface area is inversely proportional to particle size dia square. So it is, if the particle size is much lesser, this will usually they represent particle size. uh, This thing also will help you. Why finer the soil, high specific size. And remember, my dear student, as I told you already, how the diffuse double layer. What actually is diffuse double layer means? The layer on the clay surface up to the limit of attraction due to the electrical force double layer. So here, whatever the water which is held in the double layer, nothing but the adsorbed water. This adsorbed water causes. So when it causes plasticity, definitely effect on the. So we replace this fluorescein being a non-polar liquid, does not cause any plasticity to clay. I hope you have enjoyed the session, soil structure and also the origin of soils. There can be one means 1 or 2 marks from this topic, and there can be a mostly objective question. So we have seen, friends. One thing I can tell you, proudly got some aspirants who have been different. These are our toppers list which have achieved 820. If you talk about the zero fee, a GATE zero fee program is an program. IMS GATE Academy has 100 plus free live coaching, which covers 12 chapter tests, 6 subject tests, and 6 past GATE. These are the facilities are provided in your GATE program. So why are you late? Just subscribe our channel IMS GATE Academy and visit our website imsgate.com, and you will register for zero fee program. Access the free 100 hours of live class and the different mock tests associated. So here, what we do here is, here we are going to provide the 800 plus hours of live sessions, 130 plus online tests, 22 to 30 size gate book, 12 one-to-one mentor advice session. In addition to this, we are also providing the doubt solve, which where the enrolled student academy can resolve the doubt will be resolved within. So here, are you looking for the contact numbers? We have the contact number for Bangalore. We have the contact number for Vijayawada. We have the contact for Nagpur and Ahmedabad. So please look into this contact number. One thing I would like to tell you, IMS GATE Academy proudly is the offline GATE coaching center at Bangalore, here the Southern Circle, and we have another classroom office at Jayanagar. So we are really, if you are a real GATE aspirant, definitely Jayanagar IMS GATE Academy will definitely guide you. Branch, and apart from this, if you are a real GATE aspirant, Vijayawada, or you are from the native of Andhra Pradesh, no other GATE coach in Andhra Pradesh is offline. We at IMS GATE Academy are proudly saying we are the only GATE coaching center in Vijayawada, the offline GATE. So we also provide the online coaching, but definitely offline will have an. So these are the details we have situated at the bench circle, and whatever the kind of doubts, you can visit our center. See, just observe our books, exercise book, chapter books, mock test, trophy program, will show. Remember, GATE is an exam where you will be successful. The good time management, proper subject plan, proper subject flow, and the most important thing, consistency and hard work, success. I hope these sessions are really helpful. Tomorrow, my dear student, going to coming live time related text properties where you can. So if you have gone through the recording session, tomorrow's session, try to attend the live session. Definitely a much more video. Thank you.